There we go. Okay, so today, like I said, is our last lesson for chapter 4. We've talked, what seems like forever, about graphing sine and cosine. Today we're going to talk about their reciprocals, secant and cosecant, and then we're also going to talk about graphing tangent. Okay, we won't graph cotangent, but you can expect on the non-calculator part of your test to have one of each type of question as far as like a sine or cosine, a secant or cosecant, and a tangent graph. Okay. So here we go. Let's talk about what we know about secant and cosecant. Okay. I kind of already said it, but what do we know about secant and cosecant? They're the reciprocals. Secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. Okay, so let's talk about what that reciprocal means. Okay, if our sine ratio is 2/3, then our cosecant ratio is 3/2. Okay, if our sine ratio is 1/2, our cosecant ratio is 2, etc., etc. Now there is a problem. Okay. What happens? What happens when it? First of all, is it possible for sine and cosine to be 0? Okay. Well, what's the reciprocal of 0? Undefined. Okay. So we know that the reciprocal of 0 is undefined. Well, how are we going to represent that on a graph? What? Don't draw a graph? That's not what's going to happen. It's not a hole, but that's a really good idea. And you're really close. What characteristic did we talk about in conjunction with holes in the graph? Yes. Okay, so wherever we have our sine graph equal to 0, then our cosecant graph is going to have asymptotes. Same thing with cosine. Wherever the cosine equals 0, our secant graph will have asymptotes. Okay. What's really nice though, we're going to go through the parent functions for each secant and cosecant. If you can graph sine and cosine, you can graph secant and cosecant. Okay, because they're built off of those graphs. We're talking about the reciprocal graphs. Okay. So, like I said, we are going to build the parent function for each of these reciprocals, and then we'll go through an example of one with transformations. Okay. So what I'm going to ask that you do is very, very, very lightly draw the sine curve, the parent function for the sine curve. Very lightly, though. I'm actually going to make this a little bit smaller. Okay, so we just talked about wherever the sine is 0, then when we take its reciprocal, y equals the cosecant. Okay, if we were to take the reciprocal of 0, that is going to turn into an undefined value. So anytime the sine is 0, we get an asymptote for cosecant. You want to draw this. You see what's going to happen, Max?
Yeah.
What's going to happen?
It's going to look kind of like a bunch of parabolas.
I wouldn't call them parabolas, but yes, we are going to see a bunch of U's. Okay. Okay. Now, if we take, let's see, the sine of pi over 2. What's the sine of pi over 2? The sine of pi over 2 is 1. Thank you. Okay, we might get to use a circle quiz this week before our test, huh?
Yeah.
Okay. The sine of pi over 2 is 1. What's the reciprocal of 1? 1. Okay, so this coordinate gets to stay as 1. But then what's going to happen, like if we take the reciprocal of right here, like the sine of 5 pi over 6 is 1/2. Well, the reciprocal of 1/2 is 2. The reciprocal of 1/2 is 2. The reciprocal of, 2/3 becomes 3/2. The reciprocal of 5/6 becomes 6/5. And if we do that for all of our numbers, we get this U, kind of like Max talked about. And since we have asymptotes, we know those U's are going to approach the asymptotes. Okay? So that's going to happen at the extremes. Okay? Okay? So over and over and over, if we look at our cosecant graph, we're going to have asymptote U, asymptote U, asymptote U. And they're going to bounce back and forth based on the oscillation of what the sine curve will do. Okay? Now, it is up to you whether you want to draw the sine curve in very lightly or not. Some of you like to have that sine curve to base everything off of. Some of you are going to visualize it and be able to do it without. It's going to be up to you, and we'll go through an example of what that would look like. Okay? Turn to your neighbor and describe to them what the range of this graph would be. Okay, so I'm not going to ask you for the domain. The domain is not all real numbers because we have asymptotes, but we have asymptotes every so often. And describing the domain is not really something that I want you to have to worry about because the notation would be kind of tricky, and I don't want you to get hung up on that. But understand that the domain is everything except where the asymptotes are. Okay, so what I'm going to have you do is I'm going to have you identify the asymptotes for me. But don't worry about identifying the domain. However, we can identify the range fairly easily. Okay, Sydney, how would you describe our range?
We said that it would be like -infinity to -1, or the point, and then from the point at the next parabola, and then to infinity.
Okay, good. So in this case, we have -infinity to -1, and then 1 to infinity. Okay, we kind of have that gap where our sine curve is. Okay, we actually don't have any values there. Okay, so this is going to be what your range looks like. Just your numbers might be different. Okay. All right, let's look at our secant graph. Do you think it's going to have similar features? Probably, because a cosine has similar features to a sine graph. So what I'd like you to do is very lightly draw in the one period of a cosine curve. or, I mean, we can even do it right here and just scratch these out. But I want, those graphs instead of these graphs.
Yeah.
Okay, because that's what, just like, correctly, people always do those graphs, so,
Well, what would you pick? She said. Oh.
Okay, so when we go to create the secant graph, we know that the cosine is 0 at pi over 2. So we get this asymptote at x equals pi over 2. And then the cosine is also 0 at 3 pi over 2. So we get an asymptote at 3 pi over 2 as well. Okay. And then just like before, okay, on our extremes of the cosine curve, we would get those u's. So here, the cosine of pi is -1. The secant would also be -1, but then every other number gets inverted to be bigger, or I guess more negative in this case. Okay. The cosine of 0 is 1, so the secant of 0 is also 1. Okay. Cosine of 2 pi is 1, so the secant is also 1. Okay. Now, if it bothers you to only have like half of the u's because the period is cut off kind of strangely, if you want to complete those u's, if it bothers you, I have no problem with that. Okay, but technically this would be the one period of cosine. Secant. Like I said, if we can graph sine or cosine, we can graph a secant or cosecant. So I'm probably just going to do one example to save time to talk about tangent as thoroughly as we probably need to. Okay? So go ahead and copy down this equation. Yes? It would be the same. It would be the same. Thank you, Riley. The range would be the same on the parent graph for secant as it was for cosecant. Better, huh?
I felt better on Friday. Like I woke up, no fever, no anything. I was really bored that day. I had like one tail of flu and I was in fine.
I'm glad you feel better. Did you get your food shot or something? No. But you got your back.
Yeah,
That's good.
I'm not busy.
Okay, a characteristic that we do not have in a secant or cosecant graph is amplitude. Okay, a sine and cosine graph has amplitude because we bounce in between two values, right? We don't have that on these reciprocal graphs. So you are not going to identify amplitude. If there's a place for amplitude, you would write none. But it is important that we recognize that A is -2. So I'm just going to write that A is -2. Okay. Now, we do need to calculate the period the same way we would for a sine or cosine graph. Okay. So if our B value is 1, okay, our period's 2 pi. Okay. Same thing, we still need a starting point. Our starting point is still going to be C over B, comma D. Remember, this is a negative pi because it's Bx minus C. Okay, so remember, anything that I do in green means with your pencil, do it very lightly, okay? So what we're going to do is we're going to draw a frame, and we're going to draw what kind of graph very, very lightly. We're going to draw a sine graph very, very lightly, and then we can, with the dark lead, put our asymptotes and curve in for cosecant. So, just like we did Friday, here we have a starting point of negative pi, negative 2. A is 2, so we will stretch up to 0 and down to negative 4 to account for what would be the amplitude of the sine graph. Okay. And then we'll go over the period. Okay, each class is different, and it's been a weekend. Remind me, who does 1/4 of the period and adds every time? Raise your hand high. Who does the midpoint method? Okay, so method 1 is the midpoint method. Okay, yeah, it's kind of half. Okay, if you are doing the method number 2, 1/4 of the period would be pi over 2. Okay, those of you doing the midpoint method, we begin at negative pi. If we add our period of 2 pi, that means we would stop at positive pi. Hey, this is nice, right? What's the middle of negative pi and pi? 0. The middle of negative pi and 0 would be negative pi over 2, and the middle of 0 and pi would be pi over 2. Okay? Okay, and then very, very lightly, because this actually isn't a part of our graph, and you don't have to draw it if you don't need it, but I'm going to draw a negative sine curve so that I know where to put my u's and asymptotes. Okay, so there's my negative sine curve. Okay, now with dark lead, okay, we are going to put our asymptotes the same place we did in the parent graph. So in our parent graph, this would have been where the x-axis was. Now we have transformations, but those also affect our asymptotes. So wherever our sine or cosine graph hits the middle here of our frame, that's going to be where we have our asymptotes. Okay, and I am going to ask you to identify them on your test, which looks like Thursday is going to be the no calculator day. So we have an asymptote at x equals negative pi, x equals 0, and x equals pi. Okay. Then we're going to make our u's. So wherever your sine or cosine graph hits the very edge of the frame, you're going to create a u. So here we have a u. Label this point like you would if it were not the reciprocal. So negative pi over 2, negative 4. And then up here we have a coordinate, pi over 2, 0. And we're going to create a u with that one. Okay, so we are still labeling 5 items on our graph. It's just that some of them are points and some of them are asymptotes. But we're still labeling 5 critical items, I'll call it, instead of points. Okay, so anything you see in green that really wouldn't be there, we're just using that as a reference tool. Okay. Go ahead and write down what you think the range is. Guy, what's our range? Okay. We're going to put brackets on -4 and 0 because we do have coordinates there. So negative pi to -4 and 0 to pi. Okay. Basically, I mean, it's like the inverted of, excuse me, what the range would be for sine the reciprocal. All right. So that we can spend our last 20 minutes talking about tangent. I don't want to rush through tangent. We're not going to do a secant graph. But like I said, if you can graph cosine and then invert, make the u's anytime we hit the edge of the frame, make asymptotes anytime we hit the middle of the frame with our curve, you'll be fine. Okay, so make sure you practice your homework tonight. So let's talk about tangent quick. Okay, here's the unit circle. So help me out. Let's think of some special values that we have. What is the tangent here at 0?
0.
Okay, good. What about the tangent of pi over 4? What about the tangent at pi over 2? It's undefined, isn't it? So graphically, we would have an asymptote. Okay. Let's just, because we have like these two coordinates, but what else is happening? So let's think about negative pi, oh, darn it. Negative pi over 4 would be here. What's the tangent of negative pi over 4? -1. And then what would the tangent of negative pi over 2 be? Still undefined, right? Okay. This is what our tangent graph looks like. And what happens is we have these squiggles over and over and over as we rotate through the unit circle. Okay? So we have an infinite number of squiggles with an infinite number of asymptotes. But this period right here is what we're going to focus on. Okay? Little different than sine and cosine, right? What's the length here? How far horizontally before we start repeating again? Oh, this is important. The period of tangent is pi. That is different than the parent graphs of sine and cosine, isn't it? Now, we are still going to use the framing method for tangent, but it's going to look quite a bit different. Okay? So I have a new blue sheet so you can understand the differences. In our frame here. Okay, so you see on your blue sheet, we still have the same format with A tangent of bx minus c plus d. Okay? However, we have some differences because, do you see an amplitude here in our graph? We are not bouncing in between two values like sine or cosine, so once again, we have a graph that does not have an amplitude. Its period is pi, and we have asymptotes. Okay, that's very different than sine and cosine when we use the framing method for that. Okay, so we are still going to identify our starting point by C over B comma D, but look at your frames. Where's the starting point? It is in the center of your frame. So when we draw our frame, we're starting in the middle of it. So we're going to have to draw it a little bit differently, okay? We're still going to use the absolute value of A to get our vertical spacing for our frame. That's going to help us with where our squiggle is going to go, okay? The period of our tangent parent function is pi. And so to identify any horizontal stretch or shrink, we're going to calculate the period by taking pi over b instead of 2 pi over b. Okay. Now, to construct your frame, and I'm going to come back to here real quick. When we talk about the frame, this is what we're talking about right here. Okay, so you see that our starting point is in the middle. Our asymptotes are going to be on the edge. And then those quarter marks give us where these coordinates go right here. I'll have you just look at that real quick. Okay. I have two methods for you once again to calculate the horizontal spacing of your frame. So you can still do 1/4 of the period and add it 2 times and subtract it 2 times. That's method 2. Okay? If that's not your jam, then method 1 would be to split the period in half, go to the left half of the period, go to the right half of the period, and then do midpoints from there. Okay? Welcome to class. Now let me leave this here. Okay. Okay. On the frame with a positive A, wherever your frame is, the edge is where the asymptote will go. Okay. Tangent does go through your starting point, and then those quarter marks on the edge of your frame will be where you draw your curve. Okay, so once again, we're still going to be paying attention to 5 items, 3 coordinates, and 2 asymptotes for you to label. Now, if we have a graph with a negative A, okay, your starting point's still in the middle. The first thing I'll have you do is graph the asymptotes on the edge. But then A, being negative, would cause a reflection. So this quarter mark, you would have your high point. This quarter mark, you would have your low point. And then you would draw your squiggle from there. Okay. So we're still going to draw the frame with that A so we know the heights of those 2 coordinates that create our squiggle. Okay, that's the point of those. And then we're still going to draw our frame horizontally so we know how to label our asymptotes and then where those coordinates go. Okay. So we'll do one example and we'll be done. Okay. What? Let's do this. I thought you said this is confusing and then I was going to ask you what was confusing. Okay.
Come on, Mary Ann. You don't get it yet? No, I get it.
Well, we did graph sequences before using the so that's what I always want. But if you can get to the next place that we talked about, that's okay. So A is 2. That's good. Okay. What is our B value? 1. So when we calculate the period, remember tangent's kind of the oddball. We calculate it by pi over b. But since b is 1, we're still going to have a period of pi. Okay. Okay. Our starting point is still going to be c over b comma d. That doesn't change. So our starting point is going to be 0, 3. Okay. Finding the starting point is not different, but where it goes is different. Here's our starting point, 0, 3. What? Ah. Thank you. Oh, you gonna leave right now?
It's just funny how aggressive you stopped before.
Bye. Addison, you got those off from the board? Okay. Okay. So since A is 2, we are going to go up 2 and down 2. So we would stretch up to 5 and down to 1. Do you agree? Okay. Then when we draw our frame, half the period goes to the right. And since our period is pi, half of it is pi over 2. So we're going to stretch to pi over 2. Half of the period goes to the left. So to the left, we would stretch to negative pi over 2. Get there. There we go. Okay, and so then halfway between 0 and pi over 2 would be pi over 4. Okay, if you're going to choose method 2, then a fourth of the period is pi over 4, so we can add pi over 4 twice to the right, and then subtract pi over 4 twice to the left. Okay, so on the very edge is where you would draw your asymptotes. So we have one asymptote here at x equals negative pi over 2. And then on the other edge, we have an asymptote at x equals pi over 2. Okay. Starting point is a point. I always like that. Okay, and then our quarter marks give us our other coordinates. So this is a coordinate right here, and we'll label it pi over 4, 5. And this is a coordinate right here. We'll label it negative pi over 4, 1. Okay, and make it squiggle so that it approaches the asymptotes. I know it's kind of hard. I don't really have enough room vertically to make it look spectacular. Okay. Once again, I am not going to ask you for the domain on this curve because we're going to have asymptotes every period. Okay? Yes?
Do you need to have the arrows coming out of the frame?
Yes. Yes, you need to tell me that this curve continues on in both directions. Okay? Which, what would that make the range? All real numbers. The range of any tangent graph is all real numbers. How cool is that? I won't ever ask you for the domain of a tangent. I will ask you for the range, but it will be the same every time. We stretch from negative infinity to positive infinity. There's our range. Okay? Whew. We made it, guys. With 5 minutes to spare. Okay, so let's kind of review what you need to do. Those of you who want to earn points back on their quiz, you have those 2 graphs for the back. Max, if you want to write these graphs on the front and use the front, that's fine. But these are the graphs I need you to do. Okay? You also have a homework assignment. Who has their gold sheet available? So your homework comes from the 4.6. Okay, 4.6. You have 1, 2, 3, 4, 5 required graphs. That's not that many. 5 graphs. Okay. Just so you know that Miss Cronky and I are not going to do the Desmos activity. What's going to happen if you look over here at our agenda, we will have 2 days of review tomorrow and Wednesday, and then our 2-day test Thursday, Friday. Now, before you freak out about the 2-day test, it's not really a 2-day test in the fact that it's going to take you 50 minutes both days. But if we try to make it 1 day, you won't get finished with it, okay? You'll have plenty of time to do each part. It's probably more of like a 30-minute kind of test, but we can't give you a 60-minute test, okay? So we'll go over some more specifics like between tomorrow and Wednesday about the test. But 1 day will be all calculator items and 1 day will be all non-calculator items. So you kind of know how to prepare. All right, and I'm going to get you a quiz to do trash. So Emma, instead of doing I get it. No, it's okay. Okay, let me stop the recording. I need to get right in his quiz. I think that's what I was thinking about.